Now with kinematics, it's kind of the same thing as force, is you want to identify which way you're accelerating and which way you're not accelerating to choose your axes. So for instance, you know on a frictionless horizontal surface, gravity pulls straight down and there's no acceleration because nothing's pulling sideways. So therefore, this force in the x direction is 0, acceleration in the x direction is 0, and therefore v is equal to a constant. And it just moves along at constant velocity. You also know if you drop that box off a cliff, that gravity pulls it downward with the force of mg, so the acceleration is gravity about 10 meters per second squared straight down. And the velocity in the y direction is equal to acceleration times time. After 3 seconds, 30 meters per second downward. So what happens when you blast this thing off at some direction? Let's say you shoot this box as a projectile off in this direction. Well, we would break it up into v horizontal and v vertical. And horizontally speaking, what's the force? The vector sum of the forces in the x direction is 0, so there's no acceleration in the x direction, so it stops. No! So the horizontal velocity is constant. And so horizontally it would move along at constant velocity, just like if it were on this frictionless surface. Vertically, gravity's pulling on it. It's just as if you throw something up in the air and gravity accelerates it downward. So it will slow down, come to a rest, accelerate down at increasing velocity. And so we could draw its trajectory that in a moment it has the same horizontal velocity, but the vertical velocity is less. And then at that moment, after a while, it would have the same horizontal velocity, but it might be at rest now, or the vertical velocity might be negative. And after a time, you have the same horizontal velocity, but the vertical velocity increases with each passing second. And so you get a trajectory that looks like this, and we can show that this is a parabola. And that is why, when you throw something in the air, it executes its parabolic trajectory. When you throw something in the air, it executes its parabolic trajectory. If you take a hose and you shoot it off a cliff, or you pee off a bridge, am I allowed to say that? Each bit of water is acting as a projectile, and so the arc that it makes is a parabolic curve. And the concept again is this is about components. In the vertical component, you're accelerating under the force of gravity. The horizontal component stays constant.